What happens to your maneuvering speed located right here on our friendly VG or velocity versus G loading diagram when you reduce your weight? That's right, your safe maneuvering speed is lowered as the weight of the aircraft decreases. We're going to use this tragic accident as a teachable moment today here on the Blanco Lirio channel. My name's Juan Brown. Let's get into it. Starting with the Aviation Safety Network on Saturday, the 2nd of September, a Piper PA25-235, the 235 horsepower Piper Pawnee, which is a agricultural aircraft, registration X-Ray Bravo Alpha Bravo Mike, one fatality. A Piper PA25-235 Pawnee crashed after the left-hand wing failed after an emergency hopper release of pink-dyed water during a gender reveal party. The pilot did not make it. The Piper Pawnee is a light agricultural aircraft with a 150-gallon hopper located right here in front of the pilot. From the Piper Pawnee C Owner's Handbook, these aircraft have an empty weight of about 1,500 pounds, a gross weight 2,900 pounds, a useful load of about 1,377 pounds, so the hopper load is typically about 1,200 pounds. So if you got 150 gallons of water at 8 pounds per gallon, that's about 1,200 pounds worth of pink dyed water that you're going to drop. The airspeeds for the Piper Pawnee, as marked on the airspeed indicator, the green arc is 61 to 124 miles per hour. The yellow arc, 124 miles per hour to 156, with the red line at 156 miles per hour. But what I can't find in here is maneuvering speed. Aha, here it is in the type certificate data sheet from Argentina for the PA25-235. We've got VNE 156, max structural cruising speed 124 miles an hour, and a maneuvering speed of 120 miles per hour, or 104 knots. So what is the definition of maneuvering speed? This little corner of the VG diagram, which we're going to explain more here in a minute. It's the maximum speed at which you can stall the aircraft without exceeding the design load limits of the aircraft. And or also, it's the maximum speed that you can theoretically put the full control input in and stall the aircraft before you, again, exceed the design load limitations of the aircraft. Okay, great, but what's a VG diagram? Velocity along the x-axis here, indicated airspeed miles per hour versus load factor, or G's, here on the vertical axis, 0 G's being right here. Remember, you can always stall an aircraft at any indicated airspeed or any attitude, but only one critical angle of attack. But this VG diagram describes the safe operating envelope of the aircraft, and this VG diagram is drawn at the aircraft's maximum gross weight. When you reduce your weight, these numbers change. This VG diagram is just a generic VG diagram for any aircraft. However, the maximum structural load limits indicated here are that of a utility category aircraft. Now, I'm not sure if the Piper Pawnee, I know the Piper Pawnee was originally certified as a normal category aircraft, in which case its normal G limits would be 3.8 or 3.8 positive G's or 1.52 negative G's. So in the utility category, it represents a maximum positive load G factor of 4.4 G's and a maximum negative G factor of 1.76 G's. That's these two lines here. This line, vertical line here, represents the red line on the airspeed indicator. This vertical line here indicates the beginning of the caution range on the airspeed indicator. And this vertical line here indicates the normal stall speed of the aircraft in a clean configuration at the gross weight. As you begin to increase the load factor on the aircraft, pull G's on the aircraft, from stall speed up to maneuvering speed, you will stall the aircraft aerodynamically before you even reach your maximum load limit. Once you get beyond maneuvering speed, as you increase the G load, you can easily reach and exceed your maximum design load factor once you're at or beyond, flying at or beyond maneuvering speed. And again, remember, maneuvering speed is not on the airspeed indicator. It's often found as a little placard right there on the instrument panel. And then note how these stall lines kind of reach out to infinity at 0 Gs. Remember, you cannot stall an aircraft at 0 Gs. You're merely falling. So why does maneuvering speed decrease with weight? Well, one way of looking at it is back here on the VG diagram. Remember, this accelerated stall curve is directly associated to the critical angle of attack at which the wing stalls, the one and only critical angle of attack. And this entire graph is pinned right here at the normal stall speed. So when we reduce our weight, our normal stall speed decreases, i.e. we reach the critical angle of attack of the airfoil at a lower speed. And so this entire graph shifts to the left, pulling maneuvering speed down along with it. Another way of looking at it is all of this data, the grid behind the graph, shifts to the right. So the counterintuitive part of this is about the wing loading. Remember when we did the wing loading calculations during the great snowstorm? A 4,000-pound aircraft at 4 Gs, those wings are producing 16,000 pounds of lift. But as we reduce our weight, say down to a 2,000-pound aircraft at 4 Gs, those wings are only producing 8,000 pounds of lift. So it may not be the wings that fail themselves, it may be the rest of the airframe, the fixed weight components of the airframe. So the aircraft itself is reaching its maximum G limit at a much lighter wing loading. So it's not the wings that may very well fail, it may very well be all the rest of the airframe or the fixed weight components. Like, quite possibly, fuselage members. So how does this all apply to our example here? Well, first, he's obviously too low over a crowd of people, and he's coming in really fast. Dropping the nose, lining up, probably well above maneuvering speed, right up into the yellow arc. Now this is a Duster configured aircraft with an emergency hopper, so he's going to be able to dump his entire load of 1,200 pounds if he had a full hopper load of 150 gallons of pink colored water in that aircraft. He's going to be able to dump it all at once, losing 1,200 pounds almost instantaneously. So there goes the beginning of the load coming out of the aircraft, and at the same time he goes for a high G pull-up. This is exactly what you do not want to do anytime you're releasing a load from an aircraft. Why? Because you're reducing your maneuvering speed. He pulls it up so hard and so far that he quickly and suddenly exceeds the design limitations of the aircraft. He over-Gs the aircraft and snaps the left wing right at the wing spar attached fittings. As a former lead plane pilot that used to work with these S2T air tankers, I can tell you that air tanker pilots are trained to just not pull up only as required for the terrain, but instead just gently unload the wings as the retardant or water is coming out of the aircraft. Normally they drop water. Normally they drop retardant. This just happens to be a water drop. Unload the wings as you drop the retardant. The retardant is set up right on the center of gravity of the aircraft, so there's not a lot of excess trimming of the aircraft as the material is coming out. Unload the wings, keep it nice and level. They also tactically want to keep the elevation level to the terrain so that the coverage level of the retardant is consistent. But under no means do they want to yank and bank or pull hard while they are dropping their load, because of the fact that maneuvering speed decreases as you reduce the weight of your aircraft. Another problem with these airplanes, the Piper and even the air tankers, is they are older aircraft and you want to treat them gently. And in fact, there is a airworthiness directive out for the PA25 Pawnee regarding corrosion in the wing structure, the wing attach structure here as it attaches to the fuselage. If these are working aircraft spraying chemicals, this area is of great concern. And if this gets corroded and not properly inspected, this can fail even before you reach your structural design limits as designed when the aircraft were new. Unfortunately, it often takes a tragedy like this to remind us of the importance of our training and what it takes to safely operate an aircraft within the safe operating envelope of that aircraft, and also the effect of weight on maneuvering speed. If you found this information helpful, please consider liking and subscribing to the Blanco Lirio channel, and a special thanks to all the folks out there on Patreon that make this content possible. Thank you for your support. See you here.